rainbow today. And once again, that's one of only 2 Category 5 hurricanes on the Saffir-Simpson scale to hit the continental U.S. All right, moving on to the rainbow now. What happened, the light comes through the raindrops in this case, and the refraction does occur running the full spectrum, literally from red right around through the yellows, right on back into the violet. And in the case of a rainbow, what you need is to have the sun at your back and the rain still ahead of you. Looking straight out, the rain is still straight down your gaze. And what you see then is your shadow, and then out beyond the shadow you actually see the true arc of the actual rainbow itself. So in essence, everybody has their own rainbow. The guy over here is going to have the arc over here, and so on and so forth. So that rainbow is cast, and once again the colors are spread as that light is refracted, and the actual color of the red is actually on the sun side, while the actual blue is on the side away from the sun. And as you can see here, once in a while you actually get a double rainbow caused by the actual refraction of the initial rainbow back towards the second rainbow itself. Now, another optical illusion has to deal with the ice crystal clouds, and in this case we have what we call sun pillars and sun dogs, and we'll also talk about the halo and the corona around the sun.
At times it appears there's more than one sun in the sky. This is a phenomenon known as sundogs. Dennis Smith tells us why that happens.
Cirrus clouds, the thin, wispy clouds found high in the atmosphere, are made up of tiny ice crystals. They can be various shapes, sometimes hexagonal columns and sometimes hexagonal plates. It's the plate-shaped crystals that create the phenomenon known as sundogs. If the plate-shaped crystals are large enough, they fall through the atmosphere horizontally. They act as tiny prisms, refracting the sun's light through the ice crystals and back to the observer. There appears to be 3 suns, one mock sun on each side of the actual sun. Cirrus clouds normally streak out ahead of approaching front. If you get these clouds overhead, you may see a sundog, but wait for the sun to get low on the horizon and then look towards the setting sun. Sundogs are visible on average about once a week in winter and early spring across the eastern United States. I'm Dennis Smith, the Weather Channel.
Well, let's take a look at a few optical illusions now. As Dennis had mentioned, they are basically, or majority of them are formed by ice crystals in the atmosphere that are found in cirrus clouds. 2 different kinds of ice crystals. There's hexagonal plates and hexagonal columns, and they act as the prisms that reflect or refract the light and make the optical illusion. So let's go through a few slides here supplied to us by Dr. Alistair B. Fraser from Penn State, and we'll show you a few of these illusions that you may have seen on your own. The first, of course, is the sundog. Dennis already talked about that. The 2 mock suns on either side of the sun. You're most likely to see this at sunset, especially in the wintertime. Some places, like the eastern U.S., you could possibly see this once a week in the wintertime, about sunset. This is a more common optical illusion that you will see called a halo, and it can be around the sun or the moon. If it's around the sun, you're going to need sunglasses to see it. Around the moon, maybe a day before front comes in, go out at night, you have a full moon, have a perfect circle around it, and that's also formed by ice crystals. This is a sun pillar, and it looks very much like sun being reflected off of water, and it's just the sun being reflected through those ice crystals and back to you, so it makes a pillar of sun. And this is probably our most dramatic looking shot, and this is what is called a corona over the sun. Usually a perfect circle, but because the water droplets in this are of different sizes, it's kind of an odd shape, and it's giving you the rainbow effect. It's been altered. This is actually daylight, but the sun appears dark because of special photography. Again, those photos provided to us by Alistair B. Fraser of Penn State University.